minus 5 to the power of 6. Notice that the things inside the brackets is actually 2x minus 5 and that is linear. So we can use the so-called power rule of integration, okay, whereby the power plus 1 becomes a 7 over 7 and then your 2x minus 5, right? Okay, we need to take into consideration the coefficient of the x. So the 2 needs to be at the bottom and then we plus c. So that we can have 2x minus 5 to the power of 7 over 14 plus c. Okay? This is in contrast to your part F, which is to integrate square root x minus x squared with respect to x. Okay? For part F itself, you cannot apply the same manner that you did in part B to the question. Okay, you cannot power plus 1 and then so on. Okay, the reason is because the things that are found inside the brackets, it is not linear. Okay, this is square root minus x. This is 2x minus 5. Linear will mean that the power of x, right, is power of 1. It's a degree 1 polynomial. Okay, this is not a degree 1 polynomial. In fact, it's not a polynomial at all because this is x to the power of half. Okay, so therefore, what you need to do is to expand this thing, okay, using either your special identity that you learn in Sec 2 or else you do your rainbow method. Okay, so if you use the special identity, it will mean that a squared minus 2ab plus b squared. Okay, whereby your a is square root x and your b is x. Okay, and it's a minus here because it's a minus, which simplifies to x minus 2. Square root x times x would mean x to the power of half plus 1. Okay, so I do notice that some of us are still a bit weak in our indices. So half plus 1 will give us 3 over 2. For indices, we always leave it in improper fraction. Okay, so at this juncture, I have not yet done any form of integration. Okay, then I proceed to integrate now. So x plus 1 to the power becomes 2 divided by 2 minus away. This one 3 over 2 plus 1 becomes 5 over 2 divided by 5 over 2 plus x cubed over 3 plus c. Okay, then now we can simplify it. We are dividing by 5 over 2. It means the same thing as multiplying by 2 over 5, so we can flip the fraction. So 2 times 2 over 5 will give us 4 over 5 and x to the power 5 over 2. Okay, so we get that. Right? Alternatively, if you want to leave it in surds, right? You can put it as square root x to the power of 5. Okay, so that will be the answer. Right? To check our answers for integration, okay, you can actually do your differentiation to your answer. So if you differentiate all this, it should get back to the original question itself. Right? So that's why we need to really sort out our differentiation first, okay, before we do our integration. I just realized this one is, oh, okay, high section. I don't know whether she's there or not. Okay, questions? Yeah. The rest of the questions, I will come back to it when we actually handle that skill. Okay, the next one I want to do is question 2. Okay, for question 2, we are given y equals to square root 1 minus 4x squared. And we want to differentiate this. So in order to differentiate this, right, maybe we can see it as 1 minus 4x squared to the power of half. So So dy over dx using our power rule, and chain rule, bring down the power minus 1. Not forgetting to differentiate the inside, so negative 8x. So this simplifies to negative 4x over square root 1 minus 4x squared. Okay? So I do expect that at this question 2a, everyone should be able to get it right. Okay? Because that is on differentiation. Then in question 2 part B, they want you to integrate. Okay, so what you want is the integration of x over square root 1 minus 4x squared dx. The keyword in that question is hence. That means you must use part A. Okay, so how to make use of part A? Okay, the first thing that we should do, which we understand about integration, is that integration is the opposite of differentiation. So when I integrate my negative 4x over square root 1 minus 4x squared, okay, that means the result here, okay, if I integrate this, it must give me back my y, which is square root 1 minus 4x squared, and then not forgetting the plus c. Okay, so this is the bare minimum that everyone should be able to write based on understanding that integration is the opposite of differentiation. Okay, then this is the objective of the question. It is without the negative 4. We can see it as though the negative 4 is multiplying by the integral in this manner. Okay, so I did nothing to the right hand side. The left hand side, I only take out the negative 4. Okay, it is a constant number. I can only take out a number, a constant number. Cannot take out x. Okay, then because I only want this is negative 4 times the integration. So by our balancing of equation, right, we can bring this negative 4 to the right hand side, which is to divide by negative 4. Okay, so therefore on the right side, this cert itself will have to divide by negative 4. Okay, and your plus c will divide by negative 4 also, but for convenience, okay, don't stress yourself over the algebraic accuracy. Okay, just change the c to d, right? So some of you maintain c all throughout. Okay, I would recommend that change it to d okay, for it to be somewhat algebraically accurate in some sense. Okay, and then you don't confuse yourself with so many c's. Okay, so then this negative sign can actually bring out. So if you want to write it in this manner, it's also okay. I strongly encourage that don't throw away this quiz. Okay, when you practice, do look back at this to this quiz itself. Okay, and check your integration skills. Continue with where we left off yesterday. Okay, so yesterday we were looking at 16.1. I was doing a connected rates of change question. Was not done with it, so I'll finish it up today. Firstly, in the question itself, I'm not writing out a full question. Okay, we know that your dV over dt is given to be 2 cm cubed per second. And then the question also mentioned that the volume of the sphere is 150 centimeters cubed after t seconds. Okay, so when t equals to 10. So in part I, we have already formed a volume in terms of t, which is v equals to 2t plus 130 by making use of integration, where we integrated our dv over dt. Okay. Then in part 2, we have also found out what is the radius when time is equals to 2. Now in part 3, right, we want to find out what is the rate of change of radius when t equals to 2. In other words, okay, this means that we are trying to find out what is dr over dt. Okay. So in order for us to find that, okay, we do know what is dv over dt. And we can find out what is dv over dr. In fact, yesterday, did we find dv over dr? No. Okay. So yesterday we did recall also in part 2 that v equals to 4 over 3 pi r cubed. So your dv over dr will be to bring down the power of r and then power minus 1. So we get 4 pi r squared. Okay. Then, because I want to find out dr over dt, I have dv over dr and I have dv over dt. I form my connected rate of change equation by knowing that dv over dt equals to dv over dr times dr over dt. Okay. Then, your dv over dt is 2. dv over dr is 4 pi r squared multiplying by dr over dt. Okay. Question says that we want to find out what is this rate of change when time is equals to 2. Okay. But over here we're given 4 pi r squared, whereby r is radius. Okay. So we need, in fact, what is the radius when time is equals to 2? That will mean that we make use of our answer in part 2. Because at part 2, we have already found out what is the radius when time is equals to 2. So, here we substitute the r value 3.1744 and then manipulate the equation. And we will get about 0.015794. Okay, so the rate of change of radius will be 0.0158. Then in part 4, we want to find out what is the rate of change of surface area. SA, I mean surface area over here. Okay, so if I were to let A be the surface area, okay, then that will mean that what we need to find in terms of rate of change of surface area will be your dA over dt. Okay, but the problem here is that we don't have anything related to A at all. Okay, but we know that we're talking about a sphere. So surface area of a sphere is A equals to 4 pi r squared. And from here, I can find out what is dA over dr, which will be 8 pi r. Okay? So I keep to my objective whereby I want to find dA over dt, and I have dA over dr. Then the missing connection is to find out something that's related to dr. Okay? So we need a dr over dt in order to complete the equation here. Alright? And since we're looking for the rate of change when t equals to 2, we have the value of dr over dt when t is equals to 2, and that will be this value over here. Okay? So dr over dt is equals to this value when t is equals to 2. And dA over dr is 8 pi r. And dA over dt is what I want to find. Okay? So the missing piece here is the r. We are focused on finding the value when t equals to 2. So we want the r value when t equals to 2. And that goes back to our answer in part 2. We get about 1.2600. So therefore, rate of change of surface area will be 1.26 cm squared per second. Let you have a little bit of time to digest this. See if you have any questions. Okay, homework for exercise 16.1 is found on textbook page 101 onwards. Okay. Question 4F, 5B, 12, 15, and 17. Right? This shall be due on, today is Wednesday. Time passes very fast. Could we have it on next Monday? Friday? Friends say one Friday, this Friday. I am thinking that it might, I don't know whether is it challenging, because I know that we have students having the SY performance, SY showcase today lah. Okay, then after that, Thursday to anything like Friday. You want Friday? Huh? Thursday got oral. Are you sure you can do it or not? Is it you sure or not? So we next Monday lah, okay? Monday, what's the date? 16, 15. Oh, it's week 9, yeah, 15. Okay. Right. Now let's move on to go into integration of trigo. Okay, I'm writing on the board the most generic form, okay, of your trigo integration. Okay, when it comes to trigo integration, the things that are found inside, okay, your trigo function, they are always linear as well. Okay, always in the form ax plus b. Okay, I think actually in your secondary school level, we are always looking at linear forms inside lah. Okay, nothing more complicated. When you go up to your JC, okay, or if you do engineering maths, you will definitely learn more integration skills. I think integration skills are more complicated than your differentiation skills. Okay. Although ironically, okay, when it comes to the timeline, okay, of when calculus is being invented, integration did come first before differentiation. But don't know why, okay, for years and years, it's always differentiation being taught first, okay, before integration. I would say maybe because differentiation is easier to learn as compared to integration. Okay, I also don't enjoy this calculus. Okay, I admit that. Yeah, I had a very hard time in uni learning all of this or unlearning things. Okay, so integrating cosine. Okay, we get back our sine, and then we have this 1 over a over here because we're dividing based on the coefficient of the ax plus b. So likewise for sine, when we integrate, it becomes a negative cosine. Okay, and then we have our 1 over a, and integrating secant square, we get our tangent. We do not have a formula for integrating tangent itself. Okay, so because I looked at your quiz, okay, I think we need to do a little bit of practice. So let's look at try 9, okay, to really get this in. Okay, so let's take a look at integrating x plus sine x first. Okay, so integrating x plus sine x, we integrate x first, we get x squared over 2. Okay, and then we integrate sine, we will get negative cosine, so negative cosine. Since it's just a simple x, okay, we just leave it as a simple x. Okay, yes, not forgetting to plus c. Right? Looking at part B, we want to integrate pi minus cosine x. So integrating pi is a constant, we will have pi x. And then cosine, when we integrate, gives us a positive sign, so therefore the minus sign no change. And keeping the x followed by plus. The one that's further, slightly more complicated. We need to simplify this entire thing first. Always remember there's no such thing as a quotient rule or product rule when it comes to integration. Okay, so we need to simplify this by considering this half of the fraction and then the other half. So splitting it into 2 halves for that single fraction. So strictly speaking, we're saying it in this way so that we can cancel away the cosine square x. Okay, and then we will have integration of 2x. And this minus 1 over cosine square is actually secant square x. I hope you remember that secant refers to 1 over cosine. And then we integrate it bit by bit. So 2x will give us 2x squared over 2. And integrating secant square gives us tangent. So we get tangent x. Okay. The square actually doesn't play any role at all. Alright, so we are just looking at secant square itself converts to become tangent. Okay. And then 2 and 2 can simplify, so we are looking at, sorry, not dx but plus c. So we get x squared minus tangent x plus c. Then in try10, we want to integrate cosine 2x plus pi over 3. So integrating cosine becomes a positive sign. Okay. Whatever that is with the function itself, we keep it there. Okay, we don't change anything inside those brackets. Okay. However, we need to take into consideration the coefficient of x all the time, and in this case is 2, so we divide the entire thing by 2. And not forgetting to plus c. Okay? So I did notice that when it came to the quiz itself, some of you are not very familiar with the notations or the way we write mathematics. Okay, someone would have given me things like this. Alright, it's algebraically not correct and doesn't quite make sense also. You cannot see sine on its own. Okay, sine is nothing on its own. Okay, so sine must come with an angle. Alright, and the angle in this case is 2x plus pi over 3. And we're dividing the entire ratio. Okay, so sine is a trigonometric ratio. The entire ratio divide by 2. Okay, so you cannot insert a half in nowhere, okay, in the middle of nowhere. Alright? So that's the thing to know. Okay? Then part B. Integrating our secant square 2x will give us our tangent. Angle maintain the same 2x first, then we divide. Okay? And we cannot cancel the 2 away. This 2x sticks with the trigo function. Okay, so it cannot be cancelled one. Alright? It's not an algebra. Okay? So it is as good as seeing it as half tangent 2x plus c. Okay? If you really want to be strict, you can put brackets around 2x now. Okay? To represent the angle. Likewise in this, it is the same as writing half sine 2x plus pi over 3 plus. Okay? Then part C. Integrating our 3 minus sine half x. Do it bit by bit. Integrate 3, we get 3x. Okay. Then minus sine we keep. Integrate sine, we will get our negative cosine. Okay. So maybe I change the color here. Okay, so we get a negative cosine. So I'll put brackets, negative cosine half x. Then negative becomes positive. Okay, oops, I forgot one thing. This one need to divide by coefficient of x, which is divided by half. Okay. Neater. So minus becomes a plus. Dividing by half means the same thing as multiplying by 2. So we get 3x plus 2 cosine half x plus c. And lastly, for part D, to integrate 3 cosine 4x minus 1, I want us to take note that there is no brackets around the 4x minus 1. So the angle that is with the cosine okay, is actually 4x only. Okay? So this is the angle, the minus 1 does not contribute into it. So that's why we need to be very careful about how we use our brackets, okay? Or when there are no brackets, what does it actually imply? So in this case, no brackets were given. We need to recognize that 4x actually is the angle. It is not 4x minus 1. Very different from when we write it this way. Okay, because this intentionally there's brackets is telling you that 2x plus pi over 3 is the angle itself. It will matter a lot if your bracket closes here. Okay? So that means that we are saying it in two parts. We have 3 cosine 4x to integrate, followed by the 1 to integrate. Okay? So that's why being able to recognize what is angle and what is not the angle will matter. If you close your bracket after the minus 1, then we only have one thing to integrate, which is 3 cosine 4x minus 1. But now our bracket is actually closing here. We have two things to integrate. So 3 cosine 4x will integrate to give us 3 sine 4x over 4. Okay, because when we integrate cosine, we will get a positive sign. Then we integrate the minus 1, that will give us a minus x. Then we plus c. So if you want to rewrite things, you can write it as 3/4 sine 4x, that's fine. And write it this way, nothing wrong. Okay? Or you want to leave it like this, also okay. Understanding and that laid in place, going back to our quiz, how then do we integrate cosine 1 minus 2x? Okay, what do you think the answer would be? Let's choose someone. Megan, what do you think? Integrating cosine 1 minus 2x. What will we get? Integrate cosine become sine, right? Okay, then we keep the angle. Anything else? Over negative 2. Okay? So this will be the answer. Or you can write it as negative half sine 1 minus 2x plus c. Okay? And then in the other trigo function in your quiz, we want to integrate secant square. Okay, so what do you think we would be getting when we integrate secant square 2x plus pi over 3, the value? Yep. What will we get? Integrate secant square becomes tangent, then what does angle remain the same? What have we done? Our angle always remain the same, right? Okay, angle always remains the same, so we should have 2x plus pi over 3. Anything else? No? The rest of you, yes, say. Answer this first before you go. Over 2. Okay, yes. Okay. So over 2, right? Because now got a coefficient of x, okay, so need to divide by 2. Or we can write it like that. Okay. So we always think about differentiation is multiplying something. Okay. Integration has to be the reverse. We're always dividing. That's why usually I will just divide the entire thing by whatever we need to divide. Okay, rather than writing it as half on the outside. Okay? Okay, then let's look at try 11. We have time quiz. let's try 11. This goes back to our fundamental idea, okay, of integration. So we know differentiation and integration are opposite. So in part I, the question is asking us to differentiate our x cosine x. So to differentiate that, we will apply our product rule. Okay, so what will we actually get, Jovia? What's our differentiation of x cosine x? X negative sine x plus cosine x and 1. Okay, so we keep the left x, differentiate cosine will give us negative sine, and then we add, keep the right side, differentiate the left side, differentiating x will give us 1. So upon tidying things up, we get negative x sine x plus cosine x. Okay, so that will be our integration, our differentiation. Sorry. Okay, so then in part 2, it is not as straightforward as what we were doing earlier on and what we saw in our quiz itself. Okay, in part 2, the question says again, hence find out the integration of x sine x. Okay, so let us always start off with integrating, okay, whatever that we got as our answer in the earlier part. Okay, because we know that once we integrate this, it is going to become the original, which is x cosine x plus c. And we observe that what we want to find is actually found over here. So we need to do a little bit of manipulation by breaking things up. Okay, so we see that this is actually negative x sine x, integrating them with respect to x, and then we break away the cosine x into a separate integral. Okay, by adding your integration of cosine x dx. Right hand side, keep it. Okay, then we're going to move things around. Okay, either you keep this here and move this to the right, or else maybe this one to the right, everything else to the left. Really up to you. Okay, eventually I must have a positive integration. Okay, so maybe to avoid any confusion, let's just keep this to the left side. This thing we shift to the right. Okay, so we shifted this positive cosine x to the right side, which explains why it becomes a negative. Sorry, my marker is spoiled. Okay, negative integration of cosine x. And we know how to integrate our cosine x. Okay, I'm just going to keep this plus c over here. Right? So integrating your cosine x will give you your sine x. Okay? So change it into sin x. The minus sign actually follows based on the question. And not forgetting that we need to have a constant. Okay, please don't give me another plus c. That's not correct. Okay, because this c and this c, they are not the same. They may not be the same value. Alright, so choose another constant. You can do a plus d. Okay? Alright? If you want to tidy things up, you can write it as x cosine x minus sine x plus c plus d. Okay, it is not the same. Sorry. Okay, we cannot say that c plus d becomes e. Okay, we know that it doesn't make sense. It's not a plus b becomes c. We don't have such an operation. But we just find another constant to replace. Okay, like I mentioned before, we don't choose e. We choose the next letter, which is f. Okay, e we don't choose because it is a number itself. Right? So it's just to tidy things up. Okay, it really doesn't matter that you want to keep the plus c or you change it into just a single constant. We're not done, we're trying to find out positive integration. So we need to get rid of the negative sign, and that will be done so by multiplying negative over to the other side. So we have negative x cosine x plus sine x minus f. Okay? Right, so that's how we actually integrate your x sine x based on answer in part I. Okay, we don't have any form of product rule, that's why we cannot solve this alone without the help of differentiation. One last question. Okay, let's take a look at exercise 16.2, question 6. We want to integrate sine x minus cosine square, then after that equals to x minus sine square x plus c. So we want to show this. Okay? Like I mentioned earlier on, so long as inside the brackets it is not a ax plus b form, okay, you cannot do any form of power integration. That means you cannot go and take this one, add 1 and then divide. No such thing. Okay, so whenever the inside is not something linear, okay, not ax plus b, we need to expand it. Alright, so starting from the left hand side, okay, we expand first, so we get sine square x plus 2, minus 2 sine x cosine x plus cosine square x. Okay, so I'm using my a square plus b, a square minus 2ab plus b square. So this is the a, this is the b. A square minus 2ab plus b square. Okay. Upon expansion, we know that we don't have the skills to integrate sine square, neither do we have the skills to integrate cosine square. So we need to make an important observation, that is sine square plus cosine square is your identity equating to 1. Okay? So this is because sine square x plus cosine square x equals to 1. That's your identity that we learned last year. But even so, we are still not able to do any form of integration because we have a 2 sine x cosine x. And 2 sine x cosine x can't be integrated when we don't have any form of product rule. However, we also recognize that 2 sine x cosine x is equals to your double angle formula of sine, which is sine 2x. Okay. So this really explains why I gave you your little notebook of formulas. Okay, so because we need to practice recognizing these important identities. Okay. So now that we have a sine 2x, we can integrate already because 2x is the angle. It is linear. Okay, so it is in the form ax plus b, just that b is 0. Okay, so we can actually integrate sine 2x. So now we begin the integration. So integrating 1 is your x. And integrating sine, we will get our negative cosine 2x. And then not forgetting to divide by 2 because that's the coefficient of your x. And hence we get x plus half cosine 2x plus c. Okay, but we're already done with the integration. Okay, over here we want x minus sine square x plus c. How? Okay, then we need to use our formula, our identity. Which one to use? Okay, because your cosine 2x, right? If you look at your formula booklet, I'm not a working formula booklet. It's not the only paper one. Okay, so there are 3 formulas, okay, when it comes to your cosine 2x. But since our objective is to arrive at the sine square x, right? So if you can turn to your formula booklet, okay, let me just write out the 3 different identities. Okay, so these are the 3, right? When it comes to double angle for your cosine 2x, our objective is to arrive at the sine square. So naturally we should change it to this one. We shouldn't choose this, Okay, otherwise we go one big round. Alright? So therefore, cosine 2x, applying this one, we will get 1 minus 2 sine square x. And then we expand it. Okay, and then we'll have x minus sine square x, okay, plus half plus c. Alright, now you will realize that we have this plus half plus c, which definitely looks different from what the question wants you to see. Okay, we should not forget that c is supposed to be an arbitrary constant. Okay, it's just a constant number, any number itself. So actually plus half plus c can be replaced by another arbitrary constant d. It need not always be the same letter as per what the question gives you. We just see c as an arbitrary constant. So the arbitrary constant in this case is your half plus c, whereby d is actually your half plus c. Okay, so that's how we go about showing in this question. Okay. Homework for exercise 16.2. So chapter 16.2 done, huh? Let's just do question 3 and question 5. Is it okay if question 3 and 5 is due together in 16.1? Yeah. Question 3 got 3 parts, A, B, and C. So this is on page 106. Okay, so everything due on Monday. You can continue writing on the same footstep if you like to. Just make sure that it's neat. Okay. Thank you, everyone.
Thanks for watching.